How do I know? Can I speak now? Hello. I can see that there is one question by Ravi. On YouTube, links below. Yeah, yeah. Okay. So can you hear me now? Can you hear now? No sound. Okay, fine. Um, Now the question of Ravi is that how to remember the role of such large number of reagents used in organic synthesis with their mechanisms. Now the point is that first of all, you should list them out, all the reagents. Say, for example, if you are doing an oxidation of alcohol, so you should write down what are the reagents that are there for the oxidation of alcohols, and you should also see what are the mechanisms associated with it, and uh, the oh, why is there? Can you hear me? I'm not. There's an echo. Miss Bharti, I cannot stop this echo. It is coming after a few minutes. Yeah. First of all, okay. Now the question that I see by Ravi is, as I told you, that what you have to do is to list out all the oxidizing agents, for example, or reducing agents, or say later on CC bond forming reactions, and then you have to kind of go through it. Mechanism is basically to make you understand the way the yeah, but I'm getting the echo. That is the main problem. I have to worry about that. I do not know what to do. Okay. Okay. Now, Honey is asking me a question that explain the primary and secondary stereoelectronic effects in Borohydride oxidation. But I have not taught you about Borohydride oxidation. So I don't know whether it is relevant right now here for me to talk about Borohydride oxidation, because I have not talked about that. You can ask me separately by email or something like that. Hello. Hello. Sir, such your YouTube link audio is on. That's why you are getting echo. No, I have put it off. Actually, I do not understand why is it so. Then it should not come. No, but it's coming. It is coming after a few minutes. That's the problem. Or should I re-log in or re-link, rejoin the link of the YouTube? Sir, try your YouTube link to refresh. Okay, I'll just try and again. Refreshing it. Yeah, that's what I am doing it. But I think that there is a. I put it off right from the beginning. I am putting it off. Yeah, it is on. No, and it is off. I have that. It is crossing. It has crossed. I don't understand why. It should not come. Should not come. I should only be able to see the questions right from there. That's all. Yeah, yeah. For that, should I? But if I put it off the telephone mark, then I will not be able to see anything. Then the connection will be lost. So your Gmute audio is on, no? That is on. That is on. In fact, that is the only the. Yeah. YouTube has to be off. It has to be off. I have put it off, but I'm not able to. I'm getting an echo when I'm talking on this. Let me try once again then. Let me just.
Yeah. Just refresh it and off the.
Yeah.
audio.
Yeah. That I have done it.
Yeah.
Let me see.
Okay.
Huh. Mhm. Oh, everything is there. No. No, there is a problem where echo is still there. I really don't know what to do. Hello, can you hear me? Hello, can you hear me? Any one of you can say that? Can you hear me? Hello? Okay. So, uh, no, I have not written any book so far, but I'll be writing a book very soon. And that is the answer to honey. That I will be writing a book very soon, and I will have all those details of bare vinegar oxidation. Exactly what is your question? I would like to know. See, what happens is in bare vinegar oxidation, which I think others may not be right now interested, but I just want to tell you that in bare vinegar oxidation, what you have is a basically two electron three center bond, and the stereoelectronic effect means the bond that cleaves and the bond that migrates, they have to be anti-periplanar to each other. So right now, and that is where the stereoelectronic effect will come. But right now, I don't think that I would like to mention anything more than that right now, because you can then write to me later on. Okay. But any other question now you have? Any one of you? I hope you are able to understand. You ask a question. Now, if you everybody is listening and able to listen, then please ask a question. Type a question. Type a question related to what you have learned in the course that I offered. Please. Hello? Hello? There seems to be no question. So many people are there, but they are not asking any question. I can see a number of people: Aditya Dubey, Chandan Kumar, Satyam Kumar, Vikas. Honey, suggest me book for general organic chemistry. General organic chemistry, there are quite a few books. One of the books, which is a very good book, but it is very big book, is by Claydon, C-L-Y, um, C-L-A-Y-D-E-N, Claydon. It's a good book, but I do not know. You are in which? You are in MSc, I suppose. So explain about the hybridization. Okay. There are many books on general organic chemistry. Claydon is one. McMurray is another one. There are many books. If you want, please send me a mail. I will give you. Right now, I will not be able to list out all the books, but I can tell you the titles and the publishers for general organic chemistry. There are many of them, but each one of them is very big. It all depends upon what exactly you want to learn. So if you can send me a mail, I will be able to answer that. Yeah, gate examination means you have to, of course, Claydon is one good book, but Claydon alone is not sufficient. The NPTEL course that I have offered is going to help you in the synthetic part of it, whereas the mechanistic things and the conformational analysis and other things, you will have to go through general organic chemistry books. For example, as I told, Claydon, McMurray, and then there are many other books. If you write a mail to me, I will send you the list of those books. Okay. Now there is another question now by Ravi, is why Swan oxidation is replaced so many other related oxidation. See, the Swan oxidation it involves oxalyl chloride reaction with DMSO. Oxalyl chloride is relatively high boiling, in the sense around 80 degrees, not like phosgene. And when it reacts with the DMSO, it simply releases carbon dioxide, carbon monoxide, and that's all. So basically, it doesn't give you any byproduct which will not be easy, which will be difficult to remove. So that's one of the reasons why. But it also has certain limitations, which I have discussed in my lectures. But it is by and large a very, one of the major problems with this is that you have to be maintaining a temperature very low, and that becomes a problem. So, but then it is easy to handle. But similarly, Swan oxidation per se is reaction of DMSO with oxalyl chloride, but DMSO can be reacted with large number of electrophiles, as I said, acetic anhydride, trifluoroacetic anhydride, or many other this electrophilic reagents. That is how it is basically nothing but activation of DMSO with electrophiles, so that you have an electrophilic sulfur where the alcohol attacks. Okay, so that is the reason. Now, Satyajit Das is asking me, can you explain the hybridization of C6? What do you want me to know about it? What do you want to know about hybridization? I think you have a C6H5, you have a COO, C6H5. So where is the problem? There is a, you have it looks like that it is a diphenyl benzoate, and it will have sp2 hybridizations on different carbon atoms, I suppose, and maybe I do not know what exactly you want. Now, the Jovita Mary, in the Barton oxidation, phosgene is a DMSO attacking the phosgene. The first step, yes, DMSO, basically all the oxidations involving sulfur, which is similar to Swan oxidation, is basically activation of the DMSO by an electrophile, so that sulfur becomes extremely electrophilic, and there is a leaving group coming from the oxygen of the DMSO, which is now attached to an electrophile. For example, in phosgene, when a phosgene reacts, it forms OCOCl. That becomes a leaving group. If it is oxalyl chloride, then it is OCOCOCl. Like this, basically. So in phosgene, in Barton oxidation, yes, DMSO first attacks. I think I have mentioned this in my lecture. Now, can we make pyrrolidinone precursor for many therapeutics by soil oxidation? I don't know. If there is an alcohol oxidation, yes, you can do it. The only thing is that many of the nitrogen containing substrates, you have to be careful because there should not be any extra acid hanging on there. Otherwise, it will protonate. So that is the reason why excess amount of triethylamine is used so that acid gets neutralized. I hope it is understood now for Vikas. Yeah, if you tried and you are getting a mixture of product, that means you have some condition which is not working. Have you tried experimentally this reaction? Looks like that you have tried, and if you have tried it, then it may not be working. So you have to try some other oxidizing agent. For example, IBX or desmartine paradenine or something of that sort. So sometimes swan oxidation has limitation because initially to start with it is acidic. When DMSO reacts with oxalic chloride, you generate acid, and that acid can protonate the if nitrogen containing compound is there. So maybe you should not use it. Maybe you should use IBX or desmartine paradenine or something else. Now, what is the difference between sodium borohydride and Luchi reagent? I'm confused about them. Honey, you should know, and everybody else should know, sodium borohydride only along with cerium chloride or any lanthanide agent, but Luchi reagent is basically a combination of sodium borohydride with more than one equivalent of the cerium chloride heptahydrate. When the combination is used, that acts in a selective fashion to reduce an enone to the corresponding allylic alcohol, or as I had explained in my video, that aldehyde and ketone, if aldehyde and ketone both are there in a molecule, then what happens is aldehyde being more electrophilic, it gets reduced faster than the ketone. But Luchi reagent allows, as I have explained in my video, that the ketone gets reduced in preference to aldehyde. You don't have to protect it. Otherwise, you have to protect it. So sodium borohydride is a normal reducing agent which reduces all kinds of aldehydes and ketones. But if you use Luchi reagent, which is a combination of sodium borohydride with cerium chloride, then it allows specific reduction or selective reduction of, say, aldehyde versus ketone. Ketone gets reduced, enone versus ketone, enone gets reduced. Like this, there is a selectivity of the reduction of those carbonyl compounds which are otherwise not easy to reduce by sodium borohydride in selective fashion. I hope you understand, honey. Question 6 of assignment 1. What is the question 6 of assignment 1? Vikas Kumar. Let me see. What is the question? Okay. Where is the problem? Problem, as you can see that when you make the question number 6, Chandan Kumar is 6 of assignment 1. Yes. For example, when you have a sulfoxide, normally you would expect elimination in such a fashion that gives you by heating. So the reaction is being conducted at heating temperature. That means you are going to have a thermodynamic condition. Now, under these conditions, what happens is there are 3 possibilities. The 3 hydrogens can be eliminated. Question number 6, assignment number 1. One hydrogen is which is attached to the methyl. The other hydrogen is which is attached to phenyl, and the third oxygen, the hydrogen is which is attached to the carbon that contains the methoxy group. Now, in multiple answer, then why not all the possible beta hydrogen elimination? No, all the possibilities of beta halogenation are not there because that should give you thermodynamically most stable products. Now, what is the thermodynamically most stable product? The double bond in which it is most substituted, and also it is in conjugation with the phenyl ring. As I explained earlier, that the elimination of the hydrogen which is next to the methoxy group is relatively unlikely, because when the sulfoxide oxygen, after you make the sulfoxide, when the sulfoxide is there, when it is heated, the O minus of the sulfoxide takes the proton from any three possibilities. But next to the methoxy, when it is going to take the proton, that is going to abstract the proton next to the methoxy group, it will not be possible, because there will be lone pair repulsion between the sulfoxide oxygen O minus and the methoxy electrons. There will be repulsion. So that is not possible. The methyl one, which is hydrogen, which is a primary, that is possible. But then what will happen is it will also undergo rearrangement. That means isomerization to the more substitute, more stable double bond, which is in conjugation with the phenyl ring. So you might get a mixture of two products, one from the methyl side and one from the that means exomethylene, exo double bond, and the other will be from the phenyl side, but which upon heating should undergo isomerization to the more stable tetra substituted double bond. That is the way. That is why I have given you two answers, answer 2 and answer 4. Answer 4 and answer 2 both are possible, but answer that means the option number 1 is not possible because of the lone pair repulsion. I hope it is clear, Chandan. Hello. Is it clear, Chandan? So as DMSO has high boiling point, then how can we evaporate it using rotovapor as to get the desired product? There is no problem. Okay, good. There is no problem in removing. See, what happens is DMSO is also water soluble. So suppose if your aldehyde or a ketone which you have got it after the oxidation using Swan oxidation or any other activation using DMSO. So when you wash it water, the DMSO should go away, much of it. Very little amount of DMSO will be left out, that you can easily pump it out either through rotovap or through normal high vacuum pump. So there is no problem. Generally, there is no problem. You should be able to get rid of DMSO. That's absolutely no problem. Ravi, is it okay for you? Understand? Yeah, Chandan Kumar, you have got the answer properly. And Ravi, I hope you understand what I am trying to tell you. You can get rid of DMSO by washing with water if your this aldehyde or a ketone or the product that you are trying to get is not water soluble. Otherwise, you'll have to use high vacuum to remove aldehyde or this sorry, DMSO. Okay. Post the questions. Okay, Ravi, we got it. Okay, fine, good. Any other question, Chandra? I am student of your PhD student, Dr. Rima Thakur. She is my professor. Oh, very nice. I understand. Yes, of course, I remember her. She was one of the very good students of mine. Yeah. Very nice, Nandan Kumar. Yeah. So if you are, I hope you understand what I gave the explanation. Okay. Yeah, of course. Chandan Kumar, I remember her very well. She was a very good student. Excellent student. I'm sure she must be an excellent teacher also, an excellent researcher. Please ask some more questions. Please type some more questions, ask some questions. Ask a question. Satyajit Das, what is your problem with the hybridization? I don't understand. You have a benzene ring on one side, then COO C6H5, another benzene ring, which is attached to the oxygen. So one benzene ring is attached to the carbon, other is attached to the oxygen. Where is the problem? I don't understand. No questions? I hope that the videos are clear and you are able to understand what I have taught. Please give a response. It looks that most of the people have left. Questions of reagent? No. Well,